Okay, so what we're going to do is we're going to go all the way back to revising quadratics. And I've just isolated the sections that I think are the most important for you to know that kind of tie into the later topics, okay? So the one that I noticed that some of you still struggle with is completing the square. All right, so we'll have a look at that. Then we'll look quickly, very briefly at the quadratic formula, okay? Not how it's derived. If you want to go and learn that, and go and look up a video, but more importantly, the discriminant part of it, right? Because it kind of ties into the whole idea that if you know what's going on with the discriminant, you can actually work out, right, if the equation, well, especially a quadratic, has any solutions, or if it has one solution or no solutions. And I'm going to show you visually as well, right? That whole thing when they ask you to find the value for k for when the graph has got solutions. I'm going to show you a visual representation of what that might look like, just so you can possibly get a better idea of what you're actually doing. Okay, and the same can be said when we're looking at the number of intersections with a line and a quadratic. Okay, we'll move a graph up and down, and we can see what it does. So the first thing we're going to look at is completing the square. Okay, so if you want to jump back into your textbooks, we're all the way back on page, which one? All the way back to page 6. Completing the square, yeah.
Sir, did you say we should come in on Thursday or Friday?
I haven't discussed yet with Louise. I think I'm going to be there Thursday and Friday. So, and Dominic, I can just come past your house at Long Beach on my way back and drop yours off.
Oh, okay, cool. Then that'll be fine. Because yeah.
You're kind of, your mom and dad are still honeymooning, aren't they?
Yeah, they're still in the Seychelles. So then Jess and I are living with our grandparents, and like they're old, so they don't want to really go anywhere because of Corona. So like, I had to really like ask for like 5 business days to convince them to let us go shopping on the weekend to get like leafy vegetables, because I haven't had leafy vegetables in like 2 weeks.
You sound like Mrs.
Almost. Well, they eat meat and I don't, so yeah. I've had like.
I understand.
You've got to stay on the bright side, Dominique. Don't join the dark side.
I've had potatoes and onions, so like, yeah.
Russia style.
Potato bake, potato bake, and then lots of bread.
Right, let's quickly have a look at completing the square. All right, so we're not really going to go too much into it. We're just kind of going to look at the steps that we take in order to complete the square. Okay, so when we're completing the square, the whole idea is that we're trying to rewrite the expression, right, which is usually a quadratic expression, into a different form factor, right? And this form factor does 2 things. 1, it helps us solve quadratic equations. And 2, if you remember back to quadratics, it also identifies the turning point of the parabola for you without even having to go and work it out, right? Although it has to be in a very specific format for that. Okay, so there were many different form factors for completing the square, right? We're not really going to look at all of them, but we're just sort of going to look at the idea behind completing the square quickly. And then we'll do some examples. We'll do one of each kind, and then you can have a look at what's going on. Okay? So very briefly, we can just take this very simple one, x squared plus 2x minus 15. Okay. Now we would like to write this in completed square form. All right. So in the form like this, where we have x plus or minus a squared plus b. All right. And the idea being that once it's in completed square form, we can use the fact that the coordinates a, b are the turning points of the parabola. Okay? It's a very powerful tool to use. Right? We also use completing the square if we want to translate a graph. So when we look at functions on Wednesday, right, we're going to look, or sorry, Thursday, if you have the graph in completed square form, you can translate a graph much quicker as well. Right? So the steps for completing a square are very simple. Okay. If we think about just a simple expression like this, I'll just draw this offhand in a different color. When we expand out a binomial expression raised to the power of 2, the quadratic binomial, right? You already know that you get x squared, and then we get, very importantly, 2 lots of this ax, and then we just get a squared at the end, okay? And we're going to use the fact that we get 2 lots of this thing to our advantage, okay? So if we get 2 lots out, that means when we put it inside the bracket, we should just get 1 lot. In other words, if we just divide by 2. So coming back to our original equation here, when we complete the square, the first step that we do is we halve the value of b. Okay? In other words, we halve the value, right? So I can quickly write for you the standard way a quadratic expression is written. Okay, that's the standard way. So b is just the coefficient in front of the x term. So when we are completing the square, we immediately look for the term that has the x, and we're going to halve that value. Right? So we halve the value of b, and that's the figure that we're going to put in front of in the brackets square. So we're going to take x, right? We're also going to remember that the sign is attached to that b. So if it was a -2, you would take half of -2, which would be -1, right? Half of +2 is just +1. So we halve the value of the b term, and we square it, okay? Now, before we carry on, what we're going to do, again, I'm going to do this in a different color, is I'm going to show you that by doing this, without realizing it, we have created an extra figure, okay? So if I take this, just this portion here that I've now put, that I think that I've put in brackets here, let's see what this expands back out to. Okay? So if I expand this out, I'm going to get x squared plus 2
Plus 2x plus 1.
plus 1. So I have created a plus 1 in this whole scenario, which I didn't mean to create. Okay, it was created by the fact that I just put this thing in a bracket without even considering what was going on. Okay, so this is not an equation, this is an expression. And in an equation, that might have been okay, right? Because I could have just maybe subtracted 1 from both sides. But this happens to be an expression, which means that in order to keep the expression completely unchanged, whatever I add, I need to take away. All right. So if I've added 1, because of putting this thing in the back bracket, I need to actually subtract 1. All right. So we need to subtract 1 from what I've done. All right. And then we're not going to forget about this minus 15 that I still had lying around. Okay. This will give me x plus 1 squared minus 16. Okay. So what we're going to do is we're going to expand this thing out, and I should get back to my original expression, because otherwise I've changed something. Okay. So if I expand the brackets out, I get x squared plus 2x plus 1, take away 16. Right, these guys here will give me 15 or negative 15. So I haven't changed the expression. I have successfully manipulated it. All right. So that's the process about when we are subtracting that extra amount. What we're actually subtracting is the fact that we've now created a number that we need to remove, because otherwise we're changing the equation completely. Okay. So let's go again through the steps for completing the square. Okay. Now, you might have a number in front of x squared. Okay, so Dominic, if this wasn't an equation, how could I get rid of that a in order to complete the square? This is not an equation. If this was an equation, in other words, if this was equal to something, I could just divide by a and get rid of it. Yay, all right? But this is not an equation. This is an expression, which means I can't get rid of things, except I can do one thing. You don't like the number in front of something. What can you do?
You can just take it away. You can just erase it.
Why don't I just, yes, technically I can just erase it. Why don't I just factorize it out and get rid of it? Okay, because that will leave me with just x squared, except now I need to take that factor into consideration throughout the rest of them. And what I'd be left with was 2x over a minus 15 over a, right? Because if I have to expand that out again, those a's will cancel out. Okay, so if I am completing the square for an expression, right, especially an expression, and there's a coefficient in front of the x squared term, I just need to first factorize it out before I move forward. Okay, and we're going to do an example of that just now, right? But for now, let's just write down the steps, okay? So actually, step number one can be factorize out a, right? If you have a factor in front of x squared, you need to factorize it out, right? There's one exception to that, right? And that's when they actually want you to express the a inside the bracket, but we'll get to that, okay? So the first thing we're going to do is we're going to factorize out a. Step number two is we're going to take half of b. Oops, not half of b. So think to yourself, look at the term in front of x, that's the b term, and we want to think what is half of that term, okay? And in my case, half of b is just plus 1, right? Step number three, we're going to put x and half of b, so I'm just going to write b over 2 because that's easier than writing half of b, in brackets squared. Okay, so I'm going to do that. I'm going to take my x plus my half of b, which is just plus 1, and I'm going to put that in brackets squared. Okay, that's step number 3. Right, step number 4, I need to remember I've created a term, okay, which I don't want to. And that term happens to be half of b squared. Okay, and in our example, it was just 1 squared, so it stayed 1. But if we have different equations, there will be different terms, okay? But you can trust me that it's half of b squared. So we need to subtract, right? And again, I'm going to write half of b, and I want you to notice that I have that half of b squared in a bracket, and that's very important, okay? Because it's not this. Okay, that minus sign is not in the bracket with b. It's subtract whatever half of b was squared, okay? So the minus sign is in front of the bracket. So we're subtracting whatever that value is, okay? So in my example, I had plus 1 squared, so I'm going to subtract 1 squared. And step number 15 is put back your constant term. So put back c, because we've forgotten about c. It's just disappeared for a while. Okay, so put back c. Okay, and in my example, c was just negative 15. And all I have left to do is just tidy things up. So I'm going to have x plus 1 squared, take away 16, and there I have in completed square form. Now, the power of this is that I can already tell the turning point of my parabola is going to be -1, -16, because the turning point is minus b. All right, it's the opposite sign of whatever's in the bracket, right? But when it comes to the y coordinate, it's the same as the term outside the bracket.
Mr. James,
Yes, boss.
I've just realized where it isn't here.
Well,
Do you know where he
lucky for
is?
him, we record the lessons.
Oh, dang, you're right. He isn't here. Oh, well, recorded lessons.
Okay, so what we're going to quickly do is we're just going to do some examples. Right, these examples are on page 9 of your textbook. Okay. So we're going to follow the same procedures for all of these examples. Okay, factorize out a, think what's half of b, put that in brackets squared, subtract that half of b squared, which I've just added, and we're going to put back c, and then we're going to combine everything together. Okay. Now there's obviously many different forms that you can complete the square in. All right. So here they are. Right. You can have x plus a squared plus b. You can have ax plus b plus c. A minus, now this is just when you have a sad parabola, so don't stress about this one. And this is just where you have a sad parabola that's been scaled. And the final one is where sometimes we can take the perfect square of the coefficient in front of a. In other words, if the number in front of x squared is a perfect square, we can actually add it inside the bracket with it. Okay, so let's do a quick example of each of them, just so that it helps you move forward. Okay. Now, as a word of, well, maybe one of you can answer this question. If you had to choose between completing the square to find solutions or the formula, what's the easiest way to work out which is the best way? I wonder if any of you know. Because we always go, whenever we're thinking about solving solutions for a quadratic, the first thing we do is factorize. The second thing we do is try to complete the square. And the last thing is the formula, because the formula is error prone. So how would you know what's going to be better between completing the square and using the formula?
You just always use the formula.
Sometimes completing the square.
No.
Yeah. Okay. Actually, the simplest way is have a look at the numbers that you're given. Okay. If you are given fractions to try and solve solutions, the formula might be better, because completing the square with fractions can get very messy. Okay. Okay, let's have a look at one from exercise 1b. Let's go. This is just going to be in the form x plus a squared plus b. In other words, I'm not going to have a coefficient in front of x. So that's nice. Okay. So here we go. Let's go x squared minus 4x minus 8. And I would like to find the solutions to this. Okay. So step number 1 is factorize out a. Okay, I don't have an a, so yeah, step number 1 done. Okay, step number 2, think what's half of b. Okay, half of b in my example is just going to be what, Sarah?
-2.
-2, very good. Right, step number 3 is put x and half of b in brackets. Square. So here we go, x minus 2 squared. Okay, Now, because of the way I've done that, I've created an additional term, right? And that additional term is exactly half of b squared, right? So step number 4 is subtract b over 2 squared, okay? So when I write this, I'm going to write subtract, okay? I'm subtracting, and what am I subtracting? Now I'm going to open a bracket because I'm taking away whatever comes out of this, I'm taking away. I'm subtracting half of b, which I worked out to be negative 2 squared. That's what I'm taking away. All right. Step number 5, add back c, because we can't just forget about c. So c is just minus 8 in this example. Right? And the last thing is just to quickly tidy everything up. Right? So we have x minus 2 squared. That minus 2 is going to square into positive 4, except it's still being subtracted. All right, so it's still going to be negative. So it's going to be minus 4 minus 8, which is minus 12. So there we have in completed square form. And again, this will immediately give me the turning point for this parabola, which will be 2 minus 12. Everybody on the same page? We're all good?
Yep.
Okay, let's have a
Yep.
look at, let's have a look at one where we might have to factorize out a. So we want to write this in the form a x plus b squared plus c. In other words, there's going to be some number in front of the x squared term which we need to pull out. Okay. So let me have a look here. Here's a nice one. Let's go 3x squared minus 12x minus 1. All right, so go and give that a go for a second, right? And I'm going to write the steps out while you give that a go at home. Okay, so we're going to factorize out a. We're going to think what's half of b. We're going to put x and half of b in brackets squared. We're going to subtract b over 2 squared, and we're going to remember to add back c, which was our constant. So I was just writing that to give you a second, right? You should now just memorize the steps for completing the square. Okay, so the first thing we need to do is we need to factorize out a. So if I pull out a factor of 3, okay, that will leave me with my nice, right? And I'm probably going to end up having to use these big brackets. I'm going to be left with x squared minus, well, what factors out of 12 when you take out 3? You're going to get 4x. And then you're going to get, unfortunately, minus 1/3. Okay, because if I multiply 3 by negative 1/3, I will get minus 1. So there we go. I factorized out a. Right, the next thing I'm going to do is I'm going to think to myself, now I need to look inside the bracket. Okay, so I need to look inside the bracket at this guy here, not at this guy anymore, because that's not b anymore. We're looking inside the bracket. And we've actually created a separate quadratic equation inside the bracket now. We've actually just pulled out the scale factor. Okay. So half of b, Dominic, what's half of b going to be in this scenario?
Half of b would be minus 2.
There we go. So we're looking at the minus 4 inside the bracket, and half of that is just negative 2. Right, you can even write it off to the side to remind yourself, what is half of b? Sometimes half of b is not going to be a nice number. Sometimes it's going to be a nasty number. Okay. I'm just purposely picking nice ones so we don't have to deal with that right now. Okay, right, we can't forget we have this factor of 3. This is why I chose to use the big brackets, because now I need to put x and half of b in brackets squared. Okay, there we go. We've got half of b and we've put it in the bracket squared. Right, now I need to subtract whatever half of b was in bracket squared. So let's subtract here. Half of b was -2, and that's squared. And then I need to add back c. So I need to go back and look. And again, I'm looking at this c, right? Not the one from the original one, because we're not dealing with that now. We've pulled that factor of 3 out and changed what it looks like. Okay, so I need to remember to subtract 1/3. This is all in brackets squared. Oh, sorry, not in brackets squared. Okay. Okay, now all I have to do is just tidy up, right? I've still got this factor of 3. I have this x minus 2 squared in bracket. Okay. Over here, this -2 is going to square to become +4, right? So I'm going to have -4 minus 1/3. What is -4 minus 1/3, Kiana?
-4 1/3.
And what is it in a simplified fraction?
That should be 13/3.
There we go. Right? And I'm going to encourage you to write it like that, and you're going to see why in a second. Okay, so we're going to have -13/3. Right, now if we go back and look to the format that we were asked to write this in, you'll notice that the A is in front of this bracket here, right? And at the moment, I've got everything enclosed by this A. So what I'm going to do is I'm going to multiply that 3 into the bracket to complete the process. So this is going to be stuck with 3x minus 2 squared. And you can see that that 3, when it multiplies into -13/3, it's going to cancel out very nicely and just leave me with -13. Okay. And again, because it's been written in this format, right, this immediately tells me that my turning point of this graph is at 2, -13. Right, everybody happy with that so far? Right, let's look at another format, right? Now, if we quickly jump back to all the different forms, you'll notice that the ones we've done at the moment, these are just happy parabolas, that's all, okay? These ones here are exactly the same, except you're just dealing with the sad parabolas, where we have, instead of having a positive number in front of x squared, we just have a negative number in x squared, okay? So that's the only difference between those two. We will do an example just now, right? But right now, I'd like to focus on this final factor, and that's when they ask us to write as ax plus b squared plus c, all right? The only difference here is the fact that we are not going to factorize out a, all right? We're going to leave a in the expression, and we're going to deal with it, and you'll see how we'll deal with it in a second. Okay, so let me get an example quickly. Here we have 9x squared minus 6x minus 3. Okay. The first thing I want you to notice is that the number in front of x squared is a perfect square. Okay. You're usually never going to be asked to write it in this form factor unless the number in front of x squared is also a perfect square, right? The wonderful thing about that is it really does help us to quickly put this inside the bracket. Okay. So if you have a look at the expression, we have this ax, right, plus b all in brackets squared. what's going to happen when we multiply that middle term by a? Well, let's expand it out and see what we get. Okay, we're going to get a squared x squared plus 2abx plus b squared. Okay, so you'll notice that this time I have got an additional term inside over here. Okay, so who wants to venture a guess what's going to be the way we're going to deal with this?
To factor a out.
You can make A 3B2. No, not B2. Yeah.
Oh, sorry, that's not supposed to, it's supposed to be a C. Okay. Okay, there are many ways that you can do this. Okay. So if you have a look at what this expands out to become, just looking at the middle term, notice how we still get b squared out the back there. Okay, so we can either compare coefficients and create multiple simultaneous equations. Can you guys see the simultaneous equations that we need to create? You can see that a squared must equal 9.
Mm-hmm.
We have this -6 here, right? And what must that -6 equal? Well, it must equal 2ab.
I think A is -3.
And then we can take b squared plus c, and that must equal -3, okay? Except that's very confusing, isn't it? So I'm going to offer you up a different way of doing it. It can get a little bit messy because you're going to end up creating some fractions, but bear with me. So we are going to factorize out a. So if I factorize a out, what am I going to get here? I know I'm going to take out a, which is 9. I'm going to be left with x squared
-2/3x.
minus 2/3x
-1/3.
minus 1/3. Okay, now I'm just going to carry on like normal. I know it's going to get a bit messy with the fractions, but just bear with me, okay? Right, the next thing we want to think about is what is half of b? So what is half of b in this situation? What is half of -2/3?
-1/3.
No. So think about it. If you multiply 1/3 by 2, you won't get -2/3. Well, here's the easy way to do it. Take -2/3 and multiply it by half.
It's 1/3.
Ah, sorry, not multiply by 3. I'm being silly. Yes, divide by 2. Sorry. Hey, sorry. It is 1/3. I'm being an idiot. Sorry. I'm looking at the wrong notes in my book. I'm sorry. I think I took a different question to the one I had written down here. Okay, so anyways, half of b is -1/3. There we go. Okay, So step number 3 is going to be the same. We're going to take this, we're going to put x and b over 2 in brackets squared. So if we come back, we've still got this 9 over here. We have x minus 1 over 3 squared. Now we need to subtract, because we've created this extra term, b over 2 in brackets squared. So what is minus 1/3 squared?
1/9.
Okay. And we must not forget to add back c, which in our case was minus 1/3. Okay. So it's a little bit messy, but we can tidy things up, and then we're going to, once we've tidied the bracket up, we'll deal with that 9 and put it inside the bracket. Okay. So we have minus 1/9 minus 1/3. What's that going to give us? Okay, so on the sideline there, I've written minus 1/9 minus 3/9, because I've just converted that into the same denominator, gives me minus 4/9. Okay. Right, we can now deal with this 9 in the front. We're going to just multiply everything in that big bracket by 9. So we're going to get 9x minus 1/3 squared. And we're going to get minus 4. Right, how can I deal with this minus 9 in the front here? What can I do? So the way I'm going to show you this is I'm actually going to take that bracket. Right? We're just going to look at this guy separately for a second. How many of these brackets do I have, Zara?
2.
I have 2 of them. So here they are. Now, when I'm done, I want to be left with the same 2 brackets. So if I want to share this 9 evenly between them, what would I have to split it up into to not change it? Well, I need to change it into, if I change this into 3 times 3, 3 times 3 gives me 9. And now each bracket is going to get a 3. Right, so Kiana, when I put one of these 3s inside the bracket, what do I have to do? Just pretend I pulled this out as a factor, except now I want to put the factor back. What do I have to do? I need to multiply. Does it just get given to the first term?
No, you have to multiply both terms.
It's got to you've got to give it to both of it, because when you factorize, you pull out the same factor from all the terms in the bracket. So if you want to put a factor back, well, you just need to multiply the factor into everything inside the bracket, right? And now each one of these brackets, because it was a perfect square, is going to get its own 3, right? And so what we get left with is 3x minus 1 squared, okay? And we're not going to forget about our 4 over there. Now, making sense to everyone?
Mm-hmm.
Okay. Now that only works, like I said, when the number in front of x squared is a perfect square. Because if we come back to the final step, if this is not a perfect square, this number here, we wouldn't, well, we could split it evenly, except it would get very messy, right? For instance, if this number in front of x squared happens to be 7x squared, if I wanted to write that in the form ax plus b squared plus c, how would I share 7 evenly? Dominic, what would it be?
That would have to be 7/2.
It won't be 7/2. Think about it. 9/2, it doesn't give you 3. You have to give the same factor. It's got to be a number multiplied by a number, but they have to be the same. We have a special name for that. It would be the square root of 7.
Yeah.
And then you could distribute that, except then both terms inside your bracket are going to have square roots, right? And so it gets messy, and that kind of is not what the point of this whole thing was, okay? So it's usually only going to be when you have a perfect square number in front of x squared. Okay?